This video is for the Adaptive Software Systems class, specifically for assignment 2. I will start explaining my project basically by the Docker Compose file. This file will be responsible for setting up where we can basically set up all the services that we want to orchestrate. Right now my file is pretty simple. I have a web service, which is basically a Python Flask application. I created an image, a Docker image for this guy, a Docker file for this guy, and I built the image, and I also published the image at Docker Hub, so that's why it's publicly available and we're statically referencing to it. So this is the Docker file that originated this guy. It's pretty simple. Basically, it contains Python 2.7. It copies all the app files, so app.py and everything, to this guy. It does all the installation based on the requirements file, which contains Flask and Redis. And finally, it exposed port 80, and that's basically it. And then it runs the application. So coming back here, this image is basically that Docker file that I've just mentioned. It is set up in order to deploy 5 replicas. Also put some resources constraints in terms of memory and also CPU usage. This is not necessarily like it's extra, but anyways, also a restart policy in case one of the containers fail, then everything restarts. We have the port mapping here, so port 80, which is being exposed over here, is mapped to port 4000 in my host machine. Also, I'm using WebNet as my network interface, and it's declared over here. It's pretty much like an overlay interface, which is the standard Docker network interface. Besides that, we have a Redis database, a Redis instance actually, using the standard Redis image available at Docker Hub. Port mapping, we have volume being mapped here, and this is really important because my host machine volume is being mapped to the container. So whenever the container turns off, we still have the data in my host machine. Whenever it redeploys, then it basically maps back to the host machine, and we don't lose any data. Also, we only run one instance of Redis in this setup, and it's running in the manager node, which I'm going to show in a moment. And yeah, basically it does Redis service append only yes, and that's it. And it's using the same overlay network interface as the web service. And finally, we have a visualizer service. This is just for visualization. It uses a Docker sample visualizer tags table, which is pretty much, this is just an app that lets you, that uses the Docker API and lets you visualize your virtual machines that are being managed by Docker machine, and also like which containers are running in each VM. It is also set up to run in the manager, and it's a really simple application. And yeah, we're piping all the Docker socket communication here. It's going to be running on port 8080. So that's pretty much my Docker Compose file. Right now, I do have my VMs running here. I have a VM with IP 100 and one with ending on 101. Both are running the latest version of the Docker daemon. One is set up as master, the other one is node. Right now, we are actually playing with master, so whatever commands we actually execute, that's going to apply for the master virtual machine. The swarm is set up on this one in a way that this is the master, this is the node. We can create as many nodes as we want. But anyways, so besides that, if we open right now our browser, so on port 8080, we do have our visualizer here. So we have master, it's running the visualizer itself, which is this application. We have Redis, and we also have the web application, which for some reason it was decided it should be running on the other VM for balancing reason, for just balancing actually. And the application is pretty simple. It's over here. Whenever you refresh the page, it increments a count, and this count is actually on Redis. So this is being, whenever I increment here, the Flask application actually talks directly to Redis and incremented by 1. Increment the counter by 1. So if we actually open the source code here, we can see that over here it increments the counter. and that's pretty much it. And all the communication is being done again by the overlay interface. So all the containers are communicating flawlessly, and it's really easy to intercommunicate to make like all the containers communicate actually. So anyways, that's the application. It shows hello world, the host name, which is being get by socket. This is quite interesting because then we can see that the host name is basically, let me just refresh a little bit. So the host name is basically the container name that is serving the page. So yeah, this can change depending on who is serving the page, but for now it's just showing this guy, which is fine. Yeah, and we only have a single, yeah, anyways, we only have this single guy, so it makes sense. So as you can see, F3, A2 37, this is the guy that is serving the page. As we scale, we're going to see that in a second. Then we're going to have more containers for the web application, and then we may see different host names here providing the page, because you're going to have multiple containers running the application. So we can open JMeter now. For the setup, we have a pretty simple setup actually. We have 100 requests, 100 threads, and we're pointing to the IP with HTTPS and port 4000. We're just basically calling the root of the application, which is this page. And finally, we can see the results in table in a graph. And before doing that, I'm going to run a dummy scaler that was developed for this assignment. So here it asks for the threshold for the upper threshold, for the CPU upper threshold. So here I'm going to put 40, and here for the lower threshold I'm going to put 10. So this application is basically communicating directly with the Docker API and getting information about every single node that is running, every single service that is running, how many replicas each service has, and all the container IDs and everything. And right here we're checking the CPU usage, the average CPU usage for those containers. In this case, we're only looking for containers that are related to the get started web service. So going back here to the web service is this one here. Right now we only have one container, as we saw over here in the visualizer. If we come back here, we're going to notice that the set points are from 10 to 40. The CPU usage on that container is 2.10 right now, so it's pretty stable. There's no need for scaling. Also, I think that's a good time to actually check the code that we developed for the dummy scaler. So this is the dummy scaler that is running right now. Yeah, so I have some certificates here to connect directly with the virtual machines, since they require TLS. Besides that, we have their IPs here. Who is the manager? The manager IP here is where we require the input and everything. Finally, what's actually important here is this step, where we're going to do like an infinite loop, and we're going to check the services. Right now, the only service that we're going to take a look at is, the only service we're going to take a look at is the web service. So again, this service over here, that's the only one we're going to analyze. The other ones are not relevant for the moment. We don't want to scale Redis, and we don't want to scale the visualizer, since Redis it's running in a single instance, and also the visualizer, both are running on the master node. So we don't need to analyze and scale those. Those are pretty well established. So we're going to just scale the web server for now. So that's the text we're seeing over here. Analyzing the service, and it's basically calling the API and getting the container ID and everything, and calculating the CPU percentage. It's a pretty simple function that gets CPU stat, CPU usage. Basically, it calculates everything, makes a percentage, a delta, which follows the entire PID schema. And here we go. And finally, we calculate an average. Okay. And after that, yeah, we have the usage. I'm also printing the set points. So the set points are being printed constantly here. And the code is basically checks if the average is greater than the threshold. If that's the case, then it scales. If the usage is lower than the lower threshold, which is 10, then it's going to scale down. So basically, if we get more than, let's say, 40% CPU usage, it's going to scale up. And in case we get less than 40%, than 10% CPU usage, then it's going to scale down to the point that it only has like one instance running at least, but it has always one instance running, so we don't scale all the instances down. So now we can pretty much just run this and see how it goes. And let's overwrite this. And we should see a change here. Yeah, so we can see a drastic change right from spot. So CPU usage just spiked from 2.44 to 15 to 23, but still we are on the set points, like we're still on the boundaries there. The thresholds are still really good here. So there's no need to spawn like new instance right now. If we check the visualizer, we're going to see there's nothing new here. And yeah, and JMeter pretty much finished executing. So that's fine. We can run it again. But we can run it with more requests, so we can run with 600, let's say. And okay. So now we have a crazy spike here, and if we check if we visualize it here, yeah. So now we have like a CPU usage. It spiked from 17 to 291. That means that we need to provision more machines, and that we can see over here right now. We have two more machines provisioned to take the load, and also basically to justify our set points. So right now it needs to be between 10 and 40. So we're spawning machines in order to lower our CPU, so we are in our threshold, between our threshold from 10 to 40. So that's what's happening right now. More containers are being spawned. So you can see there's two more here, one here, besides the one that already existed. And now it's going down 175, since we have more containers serving the page with the web application running. That's going to 145. We're still scaling up. We're still creating more containers. As we can see, it's growing here right now. Yeah, we're getting to a good spot here. Yeah, 101. And yeah, so we're basically scaling up right now. So we have 1, 2, 3, 4, 5, 6 containers right now running the web application. So our dummy scalers are working pretty well. It's creating more and more instances till the point we have the threshold, till the point that all the set points are served well. Okay, so yeah, it's going down 75. So we're having like negative feedback here in order to just contain the traffic. And we're almost getting to the point where we have too many containers actually, and we're going to start scaling down, right? So we have 1, 2, 3, 4, 4, 5, 6, 7, 8. Yeah, 8 containers running right now. So our CPU usage is going to drop like drastically, and we're probably going to scale down. We're going to remove containers. So yeah, still have a good amount of containers here. $51. Yeah, we're getting more containers. So now we have 9 containers running. And the CPU usage is almost getting to the upper boundary. Yeah, 46, so it's almost there. Besides the visualizer, we could just call Docker Machine directly, and we also could see by using Docker Machine SSH, we could SSH to the machine and do and list the services, the nodes actually. So that's also an option, but the interface is more pleasant to follow up. So we still have, yeah, right now we have 10 instances, and we're finally getting to a point where it's getting really, really stable. So yeah, we get to a really nice point now. And now we're probably going to start scaling down because our CPU usage just went through the roof. We created a bunch of containers, and now we're removing those containers. So it's removing it right now. Should remove every single one of them. That's basically it. So it's scaling down right now. So yeah, I removed another one. So now we have 7. And yeah, one more removed. And that's pretty much what's going to happen right now. It's just going to remove a bunch of containers till the point that we have just one. And one is pretty much sufficient to do to establish the CPU usage that we have right now. So it's interesting that whenever we make a request or like a group of requests like we made here, we made 500, 600 requests. We actually saw the scaler creating new containers, which is pretty much what the code does. The code basically the scale function calls the API, and it does this request where it's basically updating the number of replicas, and depending, and this number of replicas is being supplied by this guy here, which is the task count. So basically, yeah, so if the CPU usage average is greater than the threshold, then we're going to just create one more replica. We could even put like 2 more or 3 more if we wanted. And in case it's lower than the threshold, then we're just going to subtract, which is exactly what's happening right now. And here we are. We went back to the initial state. And that's pretty much what it is. And now we are back to our thresholds. Our set points are being established here. Like we're actually doing a really good job. And that's it. Thanks for watching.